HTTPS and the TLS fragmentation together. And if you have 3 different outline servers, you can even connect the 3 servers into something similar to the onion routing. And you can also, if you want to have SOC 5 over TLS, you can combine that too as well. So you can combine multiple strategies and just use your imagination to create new strategies based on these existing built-in strategies. I will use the first one as an example. So here we have fetch and we have the destination, which is youtube.com. And we have 2 strategies linked together. Please note the sequence is actually reversed from what we type in to the command line. So in command line, we type in DNS over HTTPS first and then TLS fragmentation. But under the hood, we implement it reversely. So fetch will talk to TLS fragmentation first and then to DNS over HTTPS. So in this way, the first one will be the strategy that facing directly to the internet, and the last one will be the one facing your user code, like in this example, which is fetch. So fetch will still try to establish a TCP connection, and the TLS fragmentation doesn't care about TCP, so it will just forward that TCP connection to the next strategy, which is the DOH, DNS over HTTPS. And this strategy cares about the domain name, so it will try to send youtube.com to dns.google, try to get the IP address using HTTPS. And then it will establish the TCP connection with that IP address with youtube.com. Next, once that TCP connection is established, fetch will try to establish the TLS connection as well by sending the TLS handshake. This time, the TLS fragmentation strategy cares about it because it will try to split that into 2 records. But the DNS over HTTPS doesn't care because it only cares about domain names, so it will forward that packet directly to YouTube. And we will send the second one as well to YouTube, so that client hello is split into 2. And YouTube will return a successful TLS connection with our strategy, and we will return that connection all the way back to fetch. So in this case, fetch established a successful TLS connection with the remote website, bypassing the censorship using DNS over HTTPS and the TLS fragmentation. So that's for the composable strategies. Any questions so far?
I think we can do questions in the end.
Cool, so far so good. And next, I'd like to talk about remote measurements. So we've talked about the strategies and we've talked about all the command line tools. But we, as developers, we are going to investigate what we can use in the specific region of the censored area to bypass censorship. Typically, when you measure censorship, it requires 3 steps. First, you need to set up a remote access in the area in order to test your strategy or test what is blocked and why it is blocked. You can use outline SDK as well. For example, you can set up an outline server in the specific region and use that shadow source key. You can also use SOC 5 over SSH, like you can create an SOC 5 proxy locally and connect it to the target server using SSH, and then you can use this SOC 5 transport or strategy in outline SDK as well, so all the packets and all the traffic will be routed through this server. And a third option is some third-party providers. We are using SOCs, which is pretty easy because it supports most of the regions and ISPs in the world. But it's not free. You need to pay about $100 per month in order to use their service. But they're easy to use. And in the demo next, we will use that to show you how it is working. And once you set up the remote access, you need to detect censorship because you need to know what is censored and what you can access and what you cannot. For example, you might detect a DNS blocking to youtube.com, or you might detect the TLS client hello server name indication blocking as well, as I mentioned before. And once you detected these censorships and bypass censorships, you will need to figure out a way to bypass all these censorships using either a built-in strategy, or you can create your own strategies, or you can compose different strategies, combine them together to construct a more powerful strategy to bypass the censorship. Like here, you can use DNS over HTTPS to bypass DNS, and you can use the TLS fragmentation to bypass the SNI blocking. And you can combine them using the pipes together. Cool. We'd like to show a demo here if we have time. So I need to connect the internet.
Oh, is that
Yeah, what's the password of the Wi-Fi? So the reason the demo failed is because I didn't connect to the internet.
2024, lowercase 8.
2024.
Otherwise I can.
2024, lowercase h.
All lowercase, Hope 2024. Sorry, Hope 24. I got that on my tongue.
Hope 24. Hope 24, Hope 2024.
Yeah, I can connect to my network. Oh, it worked.
Okay, let's see. Is it working? Let me go back to the previous demo here. So I will launch the terminal here and try to run that curl command again. And it seems it's working now. We're in New York City. And as I said, we can connect to our outline server. We just pasted here. Once you click connect, it will show a status connected. And when you run the code again, it should show the IP address of the server, which is Singapore, and we host the server in DigitalOcean, so you can see all this information here. And of course, we can disconnect from the VPN server, and once it's disconnected and you run it again, it's going back to our local IP address. And it's a typical behavior of VPN server as people expected. And what I'd also like to show is you can actually share more than one keys. You can share a lot of keys. You can create a lot of keys of your own server, and you can even change the port number. So when you click the settings, it allows you to configure the host name and even port. For example, we don't like this. We want to create a port at 8080 or 80, whatever you like. When you click save and you go back to your server management, you can add a new key with that port. You can name your key, maybe another key here. And you can also share that key with your customer. And in the key, you can see the port has been changed to 8080. So you can set up the port to be any number. Changing the port is useful sometimes because most of the sensors might block unknown ports, but they will let 443 or 80 pass because they are all HTTP and HTTPS ports. So changing the port is sometimes useful. And you can also add your name, like my service here, and you can copy that key and share that with your friends. And your friend will be able to add multiple keys to the client as well. So once they add that server, it will show your own service name with the correct port number, which is 8080. And of course, your friend can connect to that server as well. And to show we are actually connected, and when you query this IP address, it will show the Singapore thing. Sometimes maybe the VPN server is slow, but we can show that here. It's from Singapore, and you can disconnect from the key, and the old key is also working. You can connect using the old key as well. But you can also revoke the access for the key in your outline manager in order to, for example, remove people there, and you can also set other data limits and other things. So outline manager is pretty useful here when you try to create your own server and share key. And we support a lot of service creation methods as well. For example, when you expand that and try to add a server, we support DigitalOcean, Google Cloud, and Amazon. And you just with a single click, an outline server will be set up successfully. I will not click that because that charges a lot of money. Not a lot, about $6 a month. But yeah, just show it, but it's slow. Cool, so that's supposed to be the first demo. Now let's jump into the second, which is measuring YouTube in Iran. For the second demo, I will not use outline or outline manager. I will switch to a new desktop here. And I will use this. Let me try to zoom in the text so people to see the
It's typically like hard to measure things in Iran because of sanctions, and it's hard to get endpoints there. But for this SOAP network, you have access to nodes there.
Yeah.
And YouTube is blocked in Iran, and typically people need a VPN to access YouTube there, but not with the Proximate strategy. You can access YouTube directly.
Right. So the first command line I will show is live. Can you see that clearly? Cool. The first command line is the fetch tool we show. You can run it directly from the command line using Go, but you still need to install Go. And then you can fetch that IP info from this Go, and I will format it as a JSON using the JQuery command. And Go will, if you run it first time, Go will try to download everything here and try to build it, and then it will run the binary. And you can see we fetched the St. John's University IP here. So that's for the fetch command. Any command can be run in this way, so you don't need to install anything from any platform. So I'm using Mac here, you can run it from or desktop environments. Maybe not mobile, but if you set up some shell in mobile, you might. Next, I'd like to show how to set up a remote connection here. So, for example, we are using a SOC server, and this is the transport we are going to use. I will first remove that because we need to add that to the previous fetch command. So this, so this is the fetch command here, and you can add the transport command line here. You can see we specify the timeout to be 10 seconds because it's pretty fast server, and you can support SOC 5 here, and we hide the SOC's credentials and SOC server address. And you can specify a specific country Here I'm using Japan, but I will skip that. I will use Iran directly. Remove all these things. You can paste your own ISP or country queries there. So for example, here I will paste in the correct Iran session. So the highlighted part is the Iran thing. We have the Iran demo session. And the country, we use the 2-character country name, IR, and also we specify the ISP as MTN Iran cell. So let's run that, and it will take an even longer time because we are actually going all the way to Iran, and but luckily, SOCKS successfully returned an Iran IP address to us, which is 5121. And you can see the ISP is MTN Iran cell, and the city is Raj, and of course the country is Iran. So we successfully support a remote access in Iran here, and the export is pretty long. So in that case, I want to save some typings by exporting an Iran SOCKS transport, and we will try to fetch YouTube from Iran SOCKS. And we expect it to fail because most of the time YouTube is blocked in Iran. And we're using the same fetch, but with the Iran SOCKS transport, try to fetch the HTTPS youtube.com. And yes, it should fail. That should be expected because we haven't added anything to it. And it will wait 10 seconds and the request failed. So timeout because it's blocked. What we suspect is maybe Iran is doing a DNS blocking. In that case, let's go back to the previous command and let's pipe in the DNS request there. The DNS over HTTPS, we're using Cloudflare as a DNS request and trying to fetch YouTube again. It should also fail as expected. That failure is not expected because I typed 2 pipes there. You only need to type 1. Let me remove that and run it again. But still, you might see different errors in this case. You might see timeout. You might see handshake failed. It all happens during my test. But today we are seeing timeout. So what I'm going to do is we think there might be some TLS SNI blocking happening there. So I will try go back to the server with the same command, but we will add the TLS fragmentation before the DNS over HTTPS. This is important, and you can think of why this is important and what's the difference between putting it before the DOH and what's the difference between putting it after the DOH. But this time, when I try to run that, it will be pretty slow because we are querying DNS servers, we are doing TLS fragmentations. We try to set up a lot of things to timeout, or we can try. Probably, let's say, hopefully it will be working this time. But if not, I will try to see whether or my
example.com.
Try to reinsure the SOCKS session is good here. I will try to fetch the IP info from the Iran SOCKS session. So network unreachable. So basically
your session, I think.
Yeah, so the session timed out, so or we need to refresh the session somehow. And sure. And but yeah, I can troubleshoot that, and people feel free to ask any questions. Yeah, some final slides here. For the DNS over HTTPS and the TLS client header fragmentation, we have an app called Intra, and it's pretty useful. You can use that to bypass censorship without needing a proxy server. Let's recap. So we talked about Outline SDK, we talked about apps, some apps, and there are a lot of third-party apps there, and you can add your own apps here as well. And here are some open source resources you can use. We published all our code on github.com, so it's all public. Thanks, and any questions? Yeah.
Your funding comes from Google, is that correct?
Yeah, for the funding.
Why does Google want to get it?
It's part of Google's like social responsibility efforts. Google wants to give back to the community, so it's being invested like millions into this area and digital rights and we are focused on that field, but it's really a way for Google to give back to society.
How would we be sure that folks are not create that door? I just feel uncomfortable with corporations that are Google.
Yeah, and I hear that, and we've been embedded in this community for like 8 years already, and the way we address those concerns is by making the code fully open source, so you can go and inspect, and we also have security audits by organizations in the digital rights community, and you're running your own server, it's not us running the servers. You can inspect the server on DigitalOcean, for instance. Like, we don't see that, and you can monitor all the traffic. Like, our clients doesn't talk to Google services unless the user is accessing Google. But you can see and monitor all those things if you want to.
Okay, cool. Yeah, well, it's on time, but if you have any questions or you want to try more things, feel free to join us at a workshop at 3 p.m. today. And you can see, you can check it in Tobin, I guess, in Tobin. Yeah, thank you.
Thank you.